Hi guys, this is Mr. Holly. Today we're going to be looking at estimating population measures of center. In doing this, we're going to be really comparing a couple things. First, we're going to be deciding whether or not it's appropriate to use the median or the mean as an estimation of center. And then secondly, we're going to be trying to make an inference about a population based on a sample. So if we have a sample of the viewers of different television programs, we're going to be deciding what we think is the average age of a viewer of that television show. So we're going to be kind of using measures of centers in a couple ways here. So here we have a couple different types of graphs. We are looking at this bar graph, and we are asked to determine whether or not it would be appropriate to use the median or the mean to describe the center. And when talking about when it's appropriate to use median, when it's appropriate to use mean, these are the things that we kind of want to think about. So first of all, if we want to use the mean, or if it is appropriate to use the mean, our data would be symmetrical, or reasonably symmetrical, okay? It would be appropriate to use the median when the data is asymmetrical, especially if it has outliers. And remember, outliers are points that lie far away from the data. Unlike other points that are mostly concentrated within some range, an outlier is going to lay far away from the rest of those points. So as I look at this on 15.1 here, and I'm looking to see, should I use mean, median, which one should I use? I see data that is essentially symmetrical, right? I can cut that in half. It looks about the same on both sides. And in that case, it would be appropriate to use the mean. Here I see data that is asymmetrical. It is skewed to the right, and because of that, we would use the median to determine the appropriate measure of center. Now, on this, number 3 here, we have data that is somewhat symmetrical to begin with, but then has an outlier and becomes a little bit asymmetrical here. So the data is skewed to the left, and because of that, we would still use the median. Now, if I flip this over, I see a box and whisker plot. And in looking at this box and whisker plot, I'm asked, do I use the median or the mean? Well, it's justifiable to say either answer. One, I could say mean, but there's a problem. If I say mean, and this is all the information I have, that's not going to be enough information because I do not have the actual data. All I have is how the data is distributed. So mean, if we have the data. Why would I use the mean? Because it's symmetrical, essentially. Okay, kind of right. All of this is kind of broken up into evenly distributed portions. If not, we would use the median because if there's no data. Because we don't actually have finding the mean is impossible with the amount of information we are currently given. Okay, let's look down here. We are looking at 3 different television programs. We are talking about the science experiments you can do, learning to read, and trivia, the game show. So these are 3 different television shows. We are going to find the sample mean for their viewership. We're calculating the mean, and I have the sample 1, sample 2, sample 3. Each one represents one of the television shows. So, sample 1, I would need to add all of these up together, and when I do, I get 61. Went ahead and did that ahead for us. Now there are 10 of these, so if I divide this by 10, I get an average of 6.1. So I can put down here for my mean, sample 1 That's this first show. The mean average is 6.1. Sample 2. If you were to add up these 10 people surveyed, their collective age is 117, divided by 10, and you would get an average age of 11.7. And sample 3, if you add those up, you would get a collective age of 549, divided by 10. Their collective age would be 54.9. So we are talking about people that are 6 years old, 11 years old, and 54 years old. Now, question 2 asks us, which show do you think each sample represents? Well, obviously, by looking at the titles, I think this is the one that's about reading, learning to read. I think this one is the one that's about science experiments that you can do, so like science for teenagers or preteens and middle school age. And then this one would be the trivia game show. That's my estimation. I feel like based on the titles, science experiments you could do would be something that would be targeted at teenagers or middle school students. Learning to read would be targeted at children. And then the trivia show is probably going to be targeted towards older folks. Okay? All right. Let's look at the next page. Here we have another sampling, sample 4, 5, and 6. These are the same 3 TV shows, and these are three different samples. On sample 4, their collective age adds up to 457. So if I divide that by 10, because there are 10 people surveyed, that's 45.7. If I add up sample 5, it's age of 74. Divide that by 10, that is an average age of 7.4. And sample 6, that is 120 divided by 10, gives me an average age of 12. All right. Alright, excuse me, sorry. So I stepped away because I wanted to confirm what I was thinking here. As we look through these, we're asked this question, which show do you think each of these samples represents? And it's still true that this one is the show about learning to read. This one is the show about science experiments. And this one is the show about trivia. But the emphasis of this question is about something that's not actually a 7th grade standard this year, and it's the idea of mean absolute deviation. And what that means is our data becomes less reliable the more variation there is from the mean, or the more deviation from the mean. So while in our previous question, all of our numbers were very close to the mean, like look, our mean here was 6.1, 6, 6, 5, 4, 8, 5, 7, 8. Everything is very close to the mean. So that data is very reliable and it's very helpful. While in this case, looking at the same television program, our mean is 7.4, but the data is 15, 5, 4, 5, 4, 3, 25, 2. So you've got a lot of deviation from that mean, or a lot of spread. Because of that, the data becomes a little less reliable. And that's really the point of mean absolute deviation, but it's not something that we're going to focus on. We will focus on interquartile range, which is actually what we see here in the next question. So I'm going to skip the rest of that question and just, we looked at the samples, we're able to determine which program, which television show goes with each sample. That is the extent of what you need to be able to do as a 7th grader. Now, when it comes to determining the range, or the measure of variation, rather, we need to be focused on interquartile range, which is what we're going to look at right here. So a movie rating website has many people rate a new movie on a scale of 0 to 100. Here's a dot plot showing a random sampling of 20 of these reviews. Would the mean or median be a better measure for center of this data? Explain your reasoning. Well, this is how we started our lesson. How would you describe this data? One, I would say there's an outlier, maybe a few outliers, and it is asymmetrical. So therefore, I would say that this data would best be served by looking at the median. So now we need to use the sample to estimate the measure of center that you chose for all the reviews. Now, when I read this question, it kind of throws me off because it says estimate. So I look at this and I'm like, oh, should I estimate? Should I look at this table and just estimate the median? And the answer is no. Like, I will find the specific median for the data that I have, but that median is an estimate for all of the viewers. So I actually need to find the median. So let's look here. I'm going to cross these out. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. All right, and then we're left with 2 points at 90. So that means we are going to have a median of 90. All right, now I'm going to erase my markings because I need to find the interquartile range. So working from, let's work, we're going to use both of these points. So cross out 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and I have this point left. So that's my lower quartile. This is my median. Lower quartile, median. Now I need to use this point, cross it out. 1, 2, 3, 4. 1, 2, 3, 4. And I should have a point right here, and that is my upper quartile. So I have an upper quartile at 95, I have a lower quartile at 80, and I have a median at 90. So if I want to draw that box and whisker plot, it would start at 10, it would go all the way up to 80, then it would go to 90, and 95, and 100. And it would look like, that's the box and whisker plot, that's how it would look. I guess this should probably be double the length here. 80 to 90 should be bigger than 90 to 95. So let's just kind of draw it to scale. 80 to 90 would look like this. Alright, so now the question asks, movies must have an average rating of 75 or more from all the reviews on the website to be considered for an award. Do you think this movie will be considered? Now, use the measure of center that you chose to justify your answer. So when this says average, it gives us the opportunity to use, it kind of uses that phrase loosely. We're able to justify this using either measure of center. We can justify this using median or mean. Now, if I was to use the mean, I'm pretty confident that the mean for this would be below 75, more than likely. I don't know what it is. I didn't calculate it. But when I use the median, as is appropriate based on the shape of the data and based on the fact that we have some outliers, using the median, I can look at this and I can see that 1, 2, 3 quartiles are above 80. That means that 75% of the people thought that this movie was 80 or better. So that is definitely, when you say an average of 75, well, half of the people thought it was 90 or better. So more than half of the people thought that it was 75. Actually, 75% of the people